you, Mr. Chairman, and this is very exciting. It's a very exciting discovery, and I'm very proud that we discovered this here in America. This is the type of thing that we have been known for in the past, and I think it's large in part not just to investment, but to the freedom that we have to investigate and explore. And again, I see it much like the Apollo program, that some of the spin-off technologies that we're going to have, not just from the discovery itself, but the tools and the technology that goes into the discovery, I think is going to benefit future generations. I've also been impressed with the large audience we've had here today, Mr. Chairman. I think this may be one of the largest audiences that we've had, and I really appreciate those students being here. This is the type of thing that I think we're setting the groundwork for future generations. In Georgia, we've had a little bit of a challenge of inspiring our young people to get into science and technology career fields. We have some of the world-class research institutes right there in Atlanta. We're leading the nation in health IT and a lot of innovations and discoveries, but yet our biggest challenge has been filling those jobs with innovators. It just seemed to be a lack of inspiration. But I'm becoming more encouraged by what I see here, and something I did yesterday. On my way to the airport, I had the opportunity to stop by one of our high schools and notify 2 students, both high school sophomores, that they had won the app challenge that Congress had put on. Ryan Cabelli of Kennesaw Mountain High School and Alvin Potter of Wheeler High School took technology. They didn't develop the technology, the coding language, but they saw a need with other students, and they took the technology someone else had discovered, and they put it into a practical application called GradeSpark. As they informed me that GPA is everything to these students, and one of the challenges students have is predicting what their GPA is going to be based off of their previous grades. So they have actually developed an app for your phone that students can put their grades in, and they can estimate where their GPA is going to be and what they need to do. And so it's taking the research others have done and put it to a practical application, which I think this next generation will be able to do that same thing. A couple of questions, though. I'm very interested in the technology you're using. I've spent 30 years in the IT sector, but the technology that you use to actually do these discoveries. But first of all, from previous questions, I was very intrigued about what you've discovered about gravity. That, from what I understand, it sounds like there's a lot of properties of gravity that's very similar to light. The speed, that there is actual waves. And I'm drawing a blank here, particles. Are we seeing more and more relationship between the two, the more you discover?
Well, yes, of course. There is a very strong relationship between the sky, what we learn about the sky from the electromagnetic and the gravitational spectrum. We are looking, I think one of the biggest, I wouldn't say surprise because we're expecting it, but one of the biggest events that we expect in the future is seeing a bright source both in the electromagnetic and the gravitational spectrum so that we can learn from the matter and the photons in there. That will be amazing, and it will happen. It will happen soon enough.
But then on the more fundamental question of the similarity of the 2 different effects, it's true that in both cases it's information that travels at the speed of light or the speed of gravity as you prefer. In both cases the effect is perpendicular to the direction of propagation of the effect. In both cases, as you make antennas longer, under the conditions of long wavelengths of information, you get bigger and bigger signals. A basic difference, though, is that a photon is a particle that travels in space-time, and we looked at space-time itself as it warped. And so it's a slightly different thing in that sense there.
So as we get to the longer tubes, if I may ask, I'm running out of time, are you already seeing I anticipate even at 4 kilometers, you're seeing the gravitational pull on your lasers, a slight, somewhat bend of...
Yeah, we see actually, so we design our instruments so that the light itself, 4 kilometers is not a lot of distance for light, and we have to design our instruments so that we take into account the curvature earlier so we can go flat. But what we do see in our instruments are the tidal effect from the moon goes around the Earth, the Earth the Earth sort of breathes because of the tidal effects, and that actually shows up on our detectors. It changes the length of our detectors by about 100 microns a day. And we actually have to, we predict it. We can correct for it, and we feed it back so that we don't have to.
Well, that was kind of my other question as far as the calibration factor from seismic activity, and I hadn't even thought about the effect of the gravitational pull on the moon. So these things, it is a lot of technology, as you alluded to, just to go into the research itself, and I applaud you on these great discoveries. Thank you.
Thank you, Mr. Loudermilk. The gentleman from Colorado, Mr. Perlmutter.